Yo, what is up, guys? It is now class time. Just a 7-minute delay, thankfully, this time. So this time you don't have to stay an extra amount of time. So today, the exciting topic of decimal. Yay! I know, not very exciting, but promise it's not hard. So if you just stick to me and pay attention during class, you should be able to multiply decimals really easily at the end of the class today. So let's get on with it. So this is a recap from a couple days ago. I'm sure you don't remember. So on day 2, we learned how to add and subtract decimals. So the basic rule is just line up the decimal point, line up the period. Hello, so it's class time currently. So if you would please mute yourself, that would be great. So the basic rule for addition and subtraction in decimals is to line up the periods. So in this week, in multiplication and division, we can't just line up the decimal points and hope it works. So there's different rules for both multiplication and for division. So you're gonna have to pay attention. So right now we're gonna learn how to multiply. And then after that, we're gonna learn how to divide. So today is short, but it's not as short as last time. So let's try something you guys understand first, obviously. So a multiplication by 10. We learned how to do that on day 1. Remember, 1 times 10 is 10. Well, 10 times 10 is 100. And then obviously the pattern here is when you multiply by 10, you're increasing an extra 0, or you're moving the place up to the left. So you're moving it to the left. So what about this? What is 0.1 times 10? If we just learned from these 2 examples that we're gonna add an extra 0 or moving it to the left by 1, so what is it gonna equal? Well, 0.01 times 10 is 0.1 because we're moving it 1 to the left. And this number times 100, you just move, oh, okay, so the typo here is supposed to be 38006 here, but it's 370, so it's 1380.6. So that's what it's supposed to be. I just made a typo there, sorry about that. And for this one, you just move this 1, 2, 3 places to the left. So now it's 240. So multiplying by power of 10, move the decimal point by that many times. You move the decimal point to the right. So what do we do with that? If the opposite for the powers of 10 are true. So what do I mean by the opposite? Also, my screen might be lagging a little bit. So yeah, the opposite. So what does that mean? Okay, so if I have 1 times 6,410, it's going to equal 6,400. That's really easy. Identity property of multiplication from day 1. And then what about 0.1? You're moving it back. Instead of moving this number forward, you're moving it backwards. So 0.1 times 6,410 equals 641. You're just removing the 0. You're moving it to the right. So instead of moving it to the left times 10, you're dividing by 10, which is 0.1, and moving it to the right. And then same thing, 0.01 times 6,410 is 64.1. As you can see a pattern, it just keeps going backwards and backwards. So now we're getting for real. This is the real multiplication. So we learned how to multiply properly before. So now let us try to multiply decimals and see how that works out. So let's multiply by not 10, 100, or 1,000. Let's multiply by different numbers. So if I have a duck that can fly 0.17 kilometers per minute, it is currently 4 minutes away from my house. So how long will it have to fly to get back? Well, what's the distance, not how much time. So what is the distance that it must travel in 0.17 kilometers per minute in 4 minutes? How long must it travel to get back to my house? So simple problem. The problem we have set up is 0.17 times 4. Oh, dang, my screen is really lagging today. So I'm gonna wait for it to load and for you guys to see. Yeah, so this is the problem. 0.17 times 4 is our problem that we're trying to solve. So how do we do that? So as always, we always set up the equation, but we line up the last digit with the 4. So instead of lining up the units digit, the 0, with the 4, obviously it's gonna be really weird. So you line up the first digit with the first digit of the next number. So in this case, the 7 with the 4. So you line those up. So now, what do we do? What's the next step? What do we do with this 0.17 and 4? Do we just multiply straight out? Well, if you think so, you might be onto something. So first we ignore the 0 point and just multiply 17 times 4. We just do some regular multiplication. So what is 17 times 4? Well, it's 8, carry the 2, and then 4 times 1 is 6. So it's gonna 17 times 4 is 68. So now what? Now what do we do? What does the 0.17 do in this equation? We just remove this, but how do we use it? How do we put it back into the solution? So now we try to put it back into the solution, the 0 point. See this decimal point? There are two numbers behind it. So the way you calculate where to put the decimal point in the final number, you count the amount of numbers after the decimal point. So in this case, 0.17 has two numbers that aren't 0, 1 and 7 after the decimal, and 4 has 0 because it doesn't have any numbers. Remember, 4.0 is equal to 4, but the zeros don't count. If it was 107, then it would count. But if it's after the number, if it's infinite zeros, it doesn't count. So if this was 0.107 times 4, then I would have 3 decimal places. But this is only 2 numbers, so I don't put a 0. Same thing. If I have 0.0717, then I would also move it back 3 because it's the numbers after the 3. The last number that isn't 0, that's what you count. So in this case, we have 2 numbers and 0 numbers in 4. So we just move the decimal point. So this is the decimal point down here. Oh, I'm gonna wait for it to load. Yep, the decimal point, 68 point. In science, you will learn that 68 point is a valid term. In math, it's not because you just have a dot. You have to put like 68.0, but it's to just show you that we have 68 dot, and then we have 68, and then we move the dot that was originally here, move it once to in between the 6 and the 8. I'm away from my screen. Move it once in between, and then move it again to the front. So now we have also two digits after the decimal point. So in decimal multiplication, we just do regular multiplication, and at the end, count how many numbers are after the decimal point, and then just move that decimal point that many times in the final solution. So simple stuff. Also, alternatively, if you want to think about it, it's just 0.17 plus 0.17 plus 0.17 plus 0.17. So 0.17 4 times. You add it 4 times. So it's kind of obvious that this makes sense. If you want to work it out by hand, you can add 0.17 4 times, and you will get 0.68. If you want to see another reason why it works, the reason that we do this is that numbers that are like 0.17 times 0.4 make sense. So how can you multiply a number by 0? How can you add a number 0.4 times? So this is a way to show you how to do that kind of multiplication. But for whole numbers, you can just add them. So what did we just learn? So we just learned that multiplying decimals multiplying a decimal and a whole number together is the same as regular multiplication, but we just move the decimal point to the places that we have the amount of digits. So easy enough. So what if we do more numbers? All right, so I want you guys to try to, oh, hold up, I'm gonna fix that. So I want you to think about what you just learned, and then I'll just change the answers so that you guys can't see the answers. All right, so now you shouldn't be able to see the answers, but attempt to do these questions, and then we will go over them in about 5-ish minutes. So these are pretty basic problems because it's just multiplication, but hopefully you understand how decimal multiplication works now. So try to solve these questions, and I'll give you until 8:52. Alrighty, guys. So looks like everyone got early. So good job, everyone. Everyone seems to have the correct answers. So let's go over them right now. Okay, yeah. Use the format, and the first one is 0.3. The second one is 1.28. Third one is 5.5. Fourth one is 16.9, and the fourth one is 14.4. Yep, good job. Everyone seems to have gotten the questions right. So nice job, everyone. All right, so we just did 1 decimal times 1 whole. Nice job, Fairwin. Good job. Everyone clap for Fairwin. Good job. You seem to have gotten this question, all these questions right. So good job on you, Fairwin. Glad you have learned. Glad for you to have learned something. So we just did 1 decimal times 1 whole number. Hopefully you can keep this trend. So today's dreaded topic: 2 or more decimals. So how do we do that? Oh no, how scary. What do you think will happen, given that I just told you how 1 decimal works? So we have an example right here. Let me get my pointer. 0.7 times 0.8. So what do we do here? Is it going to be 5.6? Is it going to be 0.056? Is going to be what is it going to be? What do you think is going to happen? So let's just I'll walk you through it. So let's go through 0.7 times 0.8. So we set up the equation like normal. Remember, for numbers, always start with the first digit, the last digit, depending on the perspective, but always start with the digits lining up. So then, remember, we just ignore the decimals for now and just do the regular multiplication. So 8 times 7 is 56, as you already know. And then I just put a decimal point here for later. And then we count. So we have one number after the decimal for 0.8 and another number in 0.7. So now you have 2 numbers in total that are behind the numbers. So that means I just move the decimal point in the front 2 times. Really simple enough. That is really basically that's all that is to multiplication. So you literally just do regular multiplication, then count the amount of numbers after the decimals, and then you just move the decimal to the correct place, which in this case is 0.56. So this makes sense, right? If I have 0.8, and then the only way to get to a number less than 0.8 is to multiply less than a number than 1, right? Because 0.8 times 1 is 0.8, 0.8 times 2 is 1.6, and when you multiply by bigger and bigger numbers, then the quotient becomes bigger and bigger and bigger. But when you multiply by smaller numbers, smaller than 1, then the answer becomes smaller and smaller and smaller. So 0.8 times 0.6 will be smaller. 0.8 times 0.5 will be even smaller, and so on. So when you multiply by a number that keeps getting smaller, you keep getting smaller numbers. And in this case, it's going to be 0.56. So this makes sense. It didn't make sense at me for first. So how did I get 0.56 from 0.8? But if you think about it, when you multiply by numbers that are bigger and bigger, you get bigger numbers. And when you multiply by numbers that keep getting smaller in intervals, then you get numbers that are smaller. So so I'll explain what this is. So this is another way to think about it. If you don't want to do the complex, well, it's pretty easy, but the hard multiplication. So how do you visualize how to multiply? So we just learned that 0.7 equals 7 times 1/10, right? Because you just multiply by 1/10 moves it backwards 1. So we just multiply by 1/10 and times 8 times 1/10. So it's just going to be equal to 7 times 1/10 times 8 times 1/10. Remember, commutative property in multiplication, we learned that day 1. So that means we can just move around the numbers, this 8 and the 1/10, and just move it like this. And then we multiply. 7 times 8, 56. 1/10 times 1/10, 1/100. We learned how to do fraction multiplication too. So this makes sense as well. So what is 56 times 1/100? 0.56, because we're moving 56 backwards twice. So that's another way to think about multiplying by 56, multiplying two decimal numbers. So that hopefully makes sense in another way. So we just proved how to multiply decimal numbers twice. So that is good. All right, so let's try. Yeah, so it makes sense now. Good job. All right, oops, I think I did that twice. So when we multiply two decimals, for instance, 1.5 and 2.8, when we multiply them together. We multiply them normally, right? 420 is 15 times 28, so that's 420. And then we count the numbers after the period. So in this case, 5 and 8. So we only have two numbers. And then we just move the decimal point in 420.0 by 2 spaces to get the answer. So we just move the decimal point from here to the 2, and then we get the answer 4.2 if we want to multiply 1.5 times 2.8. So here's some more practice for the struggling people. So we have one whole number times decimal, but we have a bunch of decimals times decimals in this as well. So hopefully you can get this one. Good luck to you if you're struggling, but I have confidence, you guys, because you guys seem to be really rocking today. Yeah, I'll give you guys about 9 o'clock EST, and then you can have a 10 minute break. If you are done, you can have a break because right now it's break time. So you can go ahead and have a, I'll say 7-minute break because you guys deserve it. 7-minute break. You can come back at 9:07 EST, and then yeah, and we're gonna learn division. So if you are done, go ahead and take a small 7-minute break since we are through class. So yep.
stop it, okay, Farron? Please. You're making a headache between my head. Please stop it. It's a headache in my brain. Please just stop it. You're gonna make a headache between my head and eyes.
You know, guys, it's break time, so you can like go and like drink some water, like go to the bathroom or like
Can they play
like
games?
eat something. I guess, but like you don't have to like annoy each
No,
other.
it's Roblox time. Mwah, ha, ha, ha. I'm officially playing Roblox. Ryan, what are you playing? I see you're online.
I'm not using the computer that I'm playing.
No, I'm not talking to you. I'm just talking to Ryan.
Oh, my bad.
He plays Roblox too, you know. Faithful Moen, 1127. What are you playing? I'm gonna join you. I'm joining you, Ryan. I'm gonna join you. And you can't stop me. Har, har, har. Ryan, where are you? Hi, Faithful. Hi, Faithful. Where are you? Oh, wait, there you are. Bro, don't kill me. Don't kill me, Ryan. Don't kill me. Help me. Don't kill me.
Sounds like you're having fun, and I hear that oof, but
Hey.
it is time to currently resume class. All right, so you've had your fun. Continue after class. So we're gonna.
Can I just kill you once, Ryan?
All right, so please mute yourself and your camera, and let us keep going. So hopefully you got these answers. I saw number one tricked a couple of you, so let's see if it tricked you. First one, 2.5. Why is it 2.5? 25 and 1. So just move the decimal point one time. So it's not 2.5. All right, second one. Oops, my bad. Second one is 0.36. Hopefully that was easy enough. 36, move it back twice. 0.36. Third one, 0.012. Hopefully that was pretty simple enough. 12, and then you just move it back 3 times. 1, 2, 3. 4, which was 0.04. It's just 40. Move back 3 times. Number 5 is 0.02. It's also simple enough. It's 2, and then you move it back twice. All right, so now the other topic for today is decimals, dividing by decimals. So how do we do that? How do you think we do that? So it's not going to be as simple as counting the decimal points after. So what exactly do we do here? I'll show you. So we just did multiplication. So after the break, let's review what we just learned. So we just did multiplication. That was easy enough. First, the step 1, regular multiplication. Line it up, set up the equation, do regular multiplication. Then we count the amount of decimals after. Oh, my camera was not on. Sorry about that. And my glasses. First, we count, and then we count the number of the amount of numbers behind the decimal. Then we move the answer back that many times. We just learned that, so easy. Is division going to be the same? Spoiler alert, it is not going to be the same. It is going to be quite different. Unlike addition, subtraction, and multiplication, there are different rules for each. So we just did multiplication. Let's do some division. So I have 560 tons of water and 1,000 pools. Don't ask, I'm just that cool. So how much water does each pool get? I know it's not a lot, but it's just a problem. So the problem is going to be 560 divided by 1,000. So how do we do that? So what is it I have to solve? How much water is going to be in each pool? So that's easy. So there are a couple ways to do this kind of questions. So I'll show you the first way to do it. They're all the same, kind of the same way, except a different ordering. So I'll show you one way to do it. Obviously, 560 times 1 is 560. 560 times 0.1, 56.0. Remember, this 0.1 is 1 over 10. 560 times 0.01, remember, 1 over 100. So 560 divided by 100 is 5.60. And 560 times 1 over 1,000 is going to equal 0.560. All right, so keep the chat, guys. Please keep the chat clean because this is class time. I don't mind during break or after class, but please keep the chat clean right now from Roblox. I don't want to see Roblox right now. I'm not playing Roblox. Don't worry about it. So please focus on class. So way 2, what is the second way that we can solve this problem? So obviously we have 560 divided by 1,000. So right now what we're trying to do is, because I showed you how to multiply, we started by multiplying by 10, then we started multiplying by 100 and 1,000. So let's first divide by 1,000. So this is what we're doing. So 560 divided by 1,000. So it's 560.0 divided by 1,000. So we have 3 zeros. So we move the 560 3 times. So it's just going to be 0.560. So this is a faster way to do it with powers of 10. But if you want to see how the process of getting there, you just go back to way 1, where you just multiply 1, 1/10, 1/100, and 1 over 1,000. So each pool gets 0.56 tons of water. I'm not sure how much that is. I'm sure that's quite a lot of water. But for a pool, the average is like it should be not that much. So division. So how do I divide decimals? If I have 2.4 meters of paper, my fifth grade class does not have 12 students. It has like 20 something, but for this example, I have 12 students. So, and they each need some paper. You guys, like, you pretend you guys are my class. I have this much paper, 2.4 meters, and each one of you, which is 12 students, needs the same amount of paper for my project. And you all want an A. So how much meters does each student get? So obviously enough, do we do the same thing as multiplication? The process is similar, but in the end, it's quite different. So this is a problem, which is 2.4 divided by 12. To solve, just divide normally, and then we add decimals. So let's try to do that. So this is the problem. So the first way is 2.4 divided by 12. 24 divided by 12 is equal to 2. So 2.4 has 1 number after decimal, so we move 1 to the right. So then 2 becomes 0.2. So let's do some practice problems. This is really, really easy. Then we're going to move on to the harder stuff. So we're going to move on to the official stuff. So this is pretty easy, regular division. Let me just move it. So something that are really tricky because I did not teach how to do these yet. So good luck on these, and then I will see you after the break. Number 3 is tricky, so watch out for that one. Okie dokie. So I think I've seen a lot of people already do these questions. So let's go over them. These are really easy. So I expect you to get them correct. First one is going to be, oh, hold up. Oh, I guess I did not write the answers, but I'll tell you the answers right now. The first one is going to be, I'm pretty sure, 0.4. And the second one is supposed to be, I think, 1.14. I'm gonna check 1.14, yeah, and then 1.33 divided by 0.7, 1.9, and then if I have 3 banners and I have a paper that's 4.05 meters long, so it's 4.05 divided by 3. So the answer for that is going to be 1.35. So yep, I did not put a answers for these, so my bad. Let's pretend I did. So all right, so estimation. Okay, I've been talking about estimation for a couple of days now. I've been talking about it for like every class. So surprise, surprise. So estimation also really helps in division. So around where is my answer? So I can approximate where it is and see if I'm correct or not. So if Florida snowed 3.2 meters in 5 days, how much did it snow in per day? So the obvious question asked is 3.2 divided by 5 is approximately what? So this squiggly equal sign just means around what it's about equal to. It's around what number? So I have the initial problem here, and I have the equation here. So the first way, obviously, is 3.2 to 3.0, because 3.0 is closer. Technically, it's not wrong to approximate up and find a range, but you should approximate to the closest number that's easy to divide by. If you divide by 3.5, it's going to be less accurate than dividing by 3.0. So if I have 3.0 divided by 5, 30 tenths. Remember we learned this last week? The 0 is in the 10th place, and a lot of th sounds. So 30 tenths, you can see why, because tenths divided by 5, 7, no, it's supposed to say 6 tenths. That is an error on my part. Again, I'm making a lot of errors today, but 6 tenths is the answer. So 6 tenths, 0.6, not 0.7. 0.6 is going to be our answer. So this is around 0.6 meters a day. Okay, so I'm gonna change that after class, so that's my bad. I cannot do it. Okay, so now is the time where we do legitimate division, actual division. So how do we do this? When you see this question and this format, this important format that we've been learning for last day, and then how do you do this? So the first obvious way to get rid of the decimals and then solve. So we just got rid of the decimal from 2.25 to 2.2525. So no decimal here. We just divide it like normal. So we have 5 and then 0, 5, right? When you divide 2525 by 5, you're going to put a 5 here because you can't divide 2 by 5 and then you move on to the next number. So 5, and then same thing here, 505. That's our answer. And then we put the decimal back. So how do we solve this? So this is our problem. So we have a decimal point right here. The way you do decimal is so simple. This is the answer. You literally just move the decimal up to the place where it is. You take this decimal, you just shove it up to the number. That's all you do. You just place the decimal here, and then you move it up. That is it. You don't have to count. You can count the numbers, but this only works for whole numbers. What about if this was 0.5? Then this number wouldn't work. So all you literally have to do is just put a 0 here. No, put a decimal and move it up. That's all you have to do. So our answer will be 5.05. So hard decimal division. Let's do a decimal divided by a decimal. So this is going to be the hardest thing we're going to learn today. So it's not too hard. Not like what we learned like last time. I think it was like super hard. So it's decimal divided by a decimal. So hardest thing today. For this, we have to think sneakily. What do we do here? 10 divided by 2 is 5, and 100 divided by 20 is 5. So what is a pattern here that you see? When you multiply 10 by 10 and 2 by 10, 100 divided by 20 is equal to 5 as well. So what you can do is multiply the top and the bottom by a number, and it will be the same. remember, we can do this because this is a fact. Because 10. Okay, so I think I'll show you guys after class. But 4 divided by 2 is equal to 2, right? Yeah, this is the example. So 4 divided by 2 is our answer, right? Times 0.1 over 0.1. Remember, 0.1 divided by 0.1 is equal to 1. So 4 over 2 times 1. That is basically what this equation is. So it's still going to be 2 times 1, but we just multiply the top and the bottom by 0.1, and it'll be the same exact equation. So if we multiply the top and the bottom by 0.1, we will get 0.4 divided by 0.2. And that's going to equal 2, because 4 divided by 2 is equal to 2. So that's how we solve these kinds of problems. So how do we apply them here? So these are really difficult because you have to find a way to make all the numbers a whole number or a decimal that you can divide by. So all you have to do is multiply this 7 by first like by 100, and then you'll get 6,300 divided by 7, and then you'll get your answer. So try to do these problems. All you have to do is just find a whole number. Try to find whole number. That both, remember, you can only do this if you multiply the top number and the bottom number by the same number. So you can only multiply 63 times 10, 0.07 times 10. You can't only multiply 0.7 times 10. So have at it. Okie dokie. Seems like a couple of you have already finished. So this shouldn't be too hard because all you're doing is just multiplying, and then it should be simple from there. So I have, for the first one, 900. Remember, we can just multiply everything by 100 and we'll get the answer. Second one is 9. Third one is 6. Fourth one is 0.8. And number 5, it was originally going to be a really hard problem, but my teacher assistant decided that you guys probably weren't up for it. So because it didn't really make sense intuitively, but for this answer, you would get $0.13 per person. So 13 cents. If my, I paused sharing. So these are the answers. Here, quick glance: 900, 9, 6, 0.8, and 0.13. Originally the question was he has $1.69, but he had 0.13 friends, and how much money does each friend get? So that didn't really make sense because you can't have 0.13 friends. But originally that was a problem, and the answer would be 13. So each friend would get $13. So yeah, that was the original problem, but I changed it, so it's simpler. So something cool. All numbers have infinite zeros. I told you about this, right? 1.39 equals 1.390 equals 1.3900 equals 1.39 with an infinite amount of zeros. The dot 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 means it goes on forever. So the infinite amount of zeros still equals 1.39. So we can't do this with whole numbers. 10 does not equal 100, and it doesn't equal 1000. We know that already. But this does work because the decimals are irrelevant for us. So we only add zeros for decimals. So how can we use this to our advantage for these kinds of problems where we can't really multiply by this number cannot be divided really evenly by 60. So we can't multiply this number by 10 and this number by 10 and then divide it. So we have to do something. We have to use this and be even more sneaky. So division is all about being sneaky. So how do you do that? So if you can see here, what we've done is we've added a 0 to 23.7, and then we just divided by 6. So first number is 23. So that can go in 3 times, minus 18, so 57. Going 9 times, 33, and I can just pull down the 0 from nowhere and then divide it by 5. If I didn't have that 0, then it would just be 3, and I can't do anything about it. So I can add an extra 0 and then bring it down, and then now it's divisible instead of being 3. So that's easy. So let's do another problem. Let's do a practice one. So how do we do this? Obviously, we do the same exact thing. So obviously the first part, the first bit is 11. Obviously minus 4. You're gonna have 1. You're gonna have 18 for this problem. You're gonna have 4. 4 can go into 18 4 times. Subtract 16, you get 2. And then for some people they'll be like, I can't do it. So obviously what we just learned, add an extra 0, and then we can solve it. From here we have an extra 0. We pull it down. Now we have 20. Now what? 20 divided by 4 is just 5. And we just solved this problem. We literally just add an extra 0, and now the problem becomes solvable. For some numbers, you can do this infinitely. You can keep adding zeros, and you'll never get there. Take 1 divided by 3, for example. So 1 divided by 3, you can put a decimal and put a 0. It will be 10. And then you subtract 9, you have 1 again. You add a 0, you have so the answer to 1 divided by 3 is 0.3333 infinitely. So that's one application of the infinite zeros. You have a number that never ends, like a pi, but that's not a number you can divide by. So numbers like rational numbers that you can divide by, the infinite zeros give a rational thought to why they exist. So I showed the answers, so that's my bad. So here are a couple that you can do on your own. Obviously, the way you would do this, first try to solve this, and then add an extra 0 at the end. So I'll try to fix this, but try not to look at the answers for now, and I'll try to fix this.
Done.
All right, should have been easy enough. I did not realize my mic was on, but that's unfortunate. So let's go on. So the first question is add an extra 0.28. Good job. Hopefully you did not like the answers. Second one, 1.6. Third one, 4.5. Fourth one, 0.72. Good job if you got all these. Not too bad. So this is a challenge problem of the day before we end class. So I just got a very small. Oh, I did not show the answers. Not bad. Okay, so I'll go back. So 2.8, 1.6, 4.5, and 0.72. Should have gotten those. If you did, good job. Nice. That was the hardest part of today. Actually, one more hard thing today, and that is the last thing we're going to learn today, and then we're going to end class. So I, Jonathan, just got, I know, but Terry, turns out we were late by 7 minutes because I was not made host yet. So this is the last thing for today, and we'll end it. So we're supposed to end in like 4 minutes, so bear with me. Jonathan, I got a small loan of $1 million from Donald Trump. Really small, not a lot of money for me. Yeah, I'm just that rich. So I spent all of it on a car, a new house, and a bunch of ducks. So I spent the rest of it on some ducks. So I bought a car that was worth $0.02 million, a house that was worth $0.5 million, and 80 ducks. So how much does each duck cost in $1 million? So I want you guys to attempt this for 2 minutes, and then I will go over this myself and show you just how much ducks cost. Yeah, guys, it's a hard question because this is a word problem. And first of all, word problems are automatically really hard because they have a lot of words. And 2, a lot of analysis. And 3, decimal division. So your favorite. So go ahead. So I like to buy a lot of ducks because I got $1 million and I don't know what else to spend it on. I bought a house, I bought a car. That's all I need. I don't need anything else. I just get ducks. Oh, my bad. All right, so I think I was muted when I said that, but apparently I said I like ducks. I spent all my money on a house and a car. I don't have anything else to spend it on, so why not spend it on some ducks? So let's try this problem, and then we'll end class. So this is the explanation. I'll walk you through it. Don't worry, it looks like a lot. So if a car that is worth this much, plus a house that is worth this much, and 80 times the cost of one duck can equal 1 million. So how do we do this? So we just first subtract 0.2, 0.5 from the million. So now it's 0.48 million equals 80 times the cost of one duck. And then 0.48 divided by 80 million is equal to the cost of one duck. So each duck costs, I think that is $5,000. So each duck costs $5,000. Don't worry, they're all golden. They all lay golden eggs. So I'll make the investment after one day. So yeah, that is the problem. So this is very basic pre-algebra, but it is pretty hard for 5th graders, honestly. So if you got that, good job. If not, try to go through it after I send the slides and try to do it yourself. Try to think about why the answer is 5,000. So that is the end for today. So good job, good luck. Yeah, the ducks cost a lot because they are golden ducks, as you see, tails. So yep, goodbye. I've been informed by my TA that is 0.06. So my TA has done some bad math, but you can now play Roblox. You can now unmute yourself, have some fun. Don't worry. Yep.
Ryan, remember to play the Roblox game with me.
I'm AFK right now, and I'm not using. I'm using a different computer. So yep. See you guys. See you. See you next time. Hopefully. Bye bye. Thank you for coming to class.
Bye.
See you, everyone. Good job. You're improving. I like to see that. Thanks. See you next time.
Bye.